Our math lesson for today is going to focus on using a unit rate as the constant of proportionality. And you can see up here that is also our objective, is for you to be able to use a unit rate as a constant of proportionality. Now, what does that mean? We will get into that today. But let's review very quickly what a unit rate is. Okay, so when we have a ratio, let's say 3:1, okay? We find our rate by dividing one number by the second number. So 3 divided by 1 would be equal to 3. 3, let's just say this stands for balloons, and this one stands for balloons not popped, okay? There should be 2 P's in popped and 2 O's in balloons. Okay, so this would be 3 popped balloons per 1 popped, or not popped balloon. Again, 2 L's in balloon. Okay, so there are three popped balloons per every 1 not popped balloon. Okay, and so this would be our rate. Okay, so for every 3 popped balloons we have, we get 1 not popped balloon. So every time we add 3, popped balloons, these are pins inside the balloon. Every time we have 3 popped balloons, we have 1 that is not popped. Okay, so if we have 6 popped balloons, that means we also have to have 1 not popped balloon. Okay, and that's using our rate. All right, and this is also how we find those equivalent ratios. Okay, we use that rate. All right, so then the unit rate is actually even simpler. The unit rate, we just take the rate. The unit rate is 3 popped balloons, or the rate is 3 popped balloons per 1 not popped balloon. The unit rate is just 3. Okay, because the unit rate says this first one out of 1. Okay, so the unit rate is just 3. Okay, or 3:1. All right, so our unit rate is 3. So that number, that unit rate of 3, we're actually going to take one step further in this lesson and use that as a constant of proportionality. And that basically would mean that the number of popped balloons is always going to be 3 times greater than the number of not popped balloons, okay? Which we saw in that ratio, but that's kind of how that unit rate or constant of as the constant of proportionality will be used, okay? Constant means it doesn't change. Proportion, okay, has to do with the proportion or a ratio. Ratios are a form of proportion. Okay, so basically the constant of proportionality is just what's that constant number that tells us the difference between the 2 parts of our ratio. Okay, so let's look at that first example. Wildlife conservationists are concerned that the deer population might not be constant across the national forest. The scientists found that there were 144 deer in a 16 square mile area of the forest. In another part of the forest, conservationists counted 117 deer in a 13 square mile area. Yet a third conservationist counted 16 deer in a 24 square mile plot of the forest. Do conservationists need to be worried? Okay. Well, we have these pieces of information. What do we need to find out? Do conservationists need to be worried? Worried about what? Well, let's go back up here. They're concerned the deer population might not be constant across the national forest. So we need to find, is the deer population constant across the national forest? Okay, so basically, are these ratios going to be equivalent? Will they be proportional to each other? And the way that we'll find that is by using a unit rate. Okay, so how do we organize this information? We have 3 separate examples with a number of deer and an area of the forest. I'm going to do that by setting up a table. Okay, but first, I suppose let's answer this question. Why does it matter if the deer population is not constant? Well, that matters to me if I want to make sure there are no predators in one area of the forest. Okay, or maybe there aren't enough plants for the deer to eat in one part of the forest. Okay, so not really a math answer there, just a real life. Why does it matter? What is the population density of deer per square mile? Okay, what this means is, what it's asking is, what number of deer do we have per square mile? Okay, so let's write down the information from our problem. And I'm going to write that down in a chart. So on the top, or on the left side, I'll put deer. And then next to that, I will put square miles. Okay, and let's create our chart. We have 144 in a 16 square mile area. We have 117 in a 13 square mile area. And then we have 216 in a 24 square mile area. All right, so what is the population density of deer per square mile? Well, we need to find out. We need to divide the number of deer per square mile, and that'll tell us out of 1 square mile. Okay, so if I just took this first, though, and wrote it as a ratio, I would have 144 to 16, and I would have 117 to 13, and then I would have 216 to 24. How would I write that as a ratio? Okay, or as a rate? How would I find the rate? I need to divide this number by this number. So what is 144 divided by 16? Well, just doing some mental math, that's 9 deer per square mile. 117 divided by 13. I do not know that one off the top of my head, so I will have to do that one. Let's see, 117 divided by 13 gives me 9 deer per square mile. Last one, 216 divided by 24 gives me 9 deer per square mile. So all of these gave me the same rate. That means that this is a constant, or that the density, or the number of deer per square mile, is constant. So that already answers the question. They're worried that it might not be constant across the forest. Well, it is, based off of these samples. Okay, so the unit rate of deer per 1 square mile is what? Well, this is our rate. How do we get from that to a unit rate? Well, we just drop this part. So it just becomes 9. The unit rate of deer per 1 square mile is 9, because there are 9 deer per 1 square mile. The constant of proportionality, then, is also going to be 9. So what does this mean? That means that there's a constant proportion between the number of deer and the number of square miles. Every time we add 1 square mile, we need to add 9 deer. Okay, so if I have 5 square miles, that's 1 square mile 5 times. That means I also need to have 9 deer 5 times. Okay, every single time we add 1 square mile, we add 9 deer, because that's how many deer there are in 1 square mile of land. Let's scroll down here and take a look. Explain the meaning of the constant of proportionality in this problem. it means there are 9 deer per 1 square mile of the forest. Use the unit rate of deer per square mile, or y divided by x, to determine how many deer there are for every 207 square miles. Okay, so what is this asking us to do? Use the unit rate of deer per square mile. Okay, what's the unit rate of deer per square mile? That's 9. Or y divided by x, okay, to determine how many deer there are for every 207 square miles. So if there are 9 deer per square mile, how many deer are there in 207 square miles? And this is where we need to figure this out. Okay, this is where we need to start using some skills. So think about it again. Anytime I have 1 mile, I have 9 deer. 1 square mile, 9 deer. Okay, so what if I have 2 square miles? How many deer would I have? Okay, 1 square mile, 9 deer. 2 square miles, because 1 and 1 is 2, I have 9 plus 9 deer. What if I have another square mile? And every time we add 1 square mile, we also have to add 9 deer. So that's why I'm drawing them in these boxes, because these are attached to each other. In fact, our ratio, or our rate is 9 deer for 1 square mile. So 9 deer and 1 square mile always have to go together. So if we have 3 square miles, we can expect there to be 27 deer, or 9 plus 9 plus 9. Okay. So what way could we figure out, without doing this addition, what if we have 3 square miles? How many deer will there be? If we have 3 square miles, how many deer will there be? Well, we counted up here. 1 plus 1 plus 1, 9 plus 9 plus 9. Okay, so if we have 3 square miles, that means we also need to have 3 groups of 9 deer. Because 1 mile at a time, we need 3 of those to make 3 square miles. So we need 3 groups of 9 deer at the same time. How many is 3 groups of 9? We show that by 3 times 9. Okay, maybe you remember this from when you were younger. Okay, let's just do stars. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, this is one group of 9 stars. Okay, and I'm just going to pause while I fill in the rest of this for the example. All right, so this is one group of 9, 2 groups of 9, 3 groups of 9. What's an easier way to do this instead of counting up? Multiplication, right? That's what multiplication is. We're saying this is how many groups of this number we have. So here we're multiplying 3 groups. We're saying we have 3 groups of 9. So 3 times 9 would tell us how many deer we have. Okay? Because there's 1 square mile in each group. Because there's 1 square mile in each group, we just can multiply the number of square miles times 9, because there are 9 deer for 1 square mile. Okay? So let's go back to the problem here. It says there are 207 square miles. How many deer will that be? Well, now instead of 3 groups, we have 207 groups of 9 deer. So we would do that by multiplying 207 times 9. Okay, because now we don't have 3 square miles, we have 207. 207 times 9 gives us the number of deer in 207 square miles. Because if there's 1 square mile, we have 9 deer. So every time there's 1 more mile, we need to add another 9 deer. And we would need to do that 207 times add 9. 207 times we're going to add 9. So instead, we can have the shortcut of just multiplying 207 times 9. And the reason we use 9 is because it is our unit rate, which we are using as a constant of proportionality. Okay, it's the difference between the number of square miles and the number of deer. Okay, it's a number we can multiply or divide by. So 207 times 9, let's just do some quick mental math. Well, 9 times 2 is 18. Okay, then we have to add that 0. But then 7 times 9 is 63. So I should have 1,863 deer. All right. How are we feeling after that one? I think we might need some examples instead of completing this entire lesson. But we'll finish this problem up at least. Use the unit rate to determine the number of square miles in which you would find 486 deer. All right, so here we're working the opposite direction. We're starting with the number of deer, and we need to find the number of square miles. The process is very similar, but a little different. But we need to remember what that constant of proportionality means. That 9 means that there are 9 deer in 1 square mile. So if we have 486 deer, we need to find out how many square miles. Oh, what am I doing? We need to find the number of square miles. I'm just going to put a question mark there because we don't know. Square miles, we don't know. However, we do know that there are 9 deer in 1 square mile. So what could we do here to figure out how many square miles there are if we have 486 deer? Well, remember again, every time we have 1 square mile, we have 9 deer. Every single time. So let's see. If I have all these deer, and I would split them into groups of 9, because there are 9 deer in 1 square mile, that should actually give me the number of square miles. If I divide 486 into equal groups of 9, that should give me the number of square miles. Because, remember, we only can have 9 deer in a square mile. So how many groups of 9 deer are in 486? I don't know. Okay, I don't know. But let me try writing this as an equation to maybe help us a little bit. Okay, so I know that I have 9 times some number equals 486. 9 times some number equals 486. Okay, and that question mark is the number of square miles, because 9 times the number of square miles, because there are 9 deer in 1 square mile, okay, 9 times the number of square miles equals 486. Well, what if I change that from a question mark into a variable? Let's just say this is a S for square miles. 9 times S equals 486. Okay. So this is what we're dealing with here. We have a multiplication problem that we don't know the answer to. But what if we were trying to get the variable S alone to figure out what equals the number of square miles? Well, we would want to do the opposite operation. Right now, this 9 is in the way. we would have to divide because 9 is being multiplied by s. So to get rid of that, we would divide by 9. 9 divided by 9 equals 1. Okay, 1 times s is just s. S equals, well, remember, what I do to one side, I have to do to the other side. So if I divide 486 divided by 9, what do I get? Let's see. Again, mental math, I think that's going to come out to 54, but let me do it on the calculator. Yeah, 54. 54. And what does that 54 mean? What does s equals 54 mean? That was what we were solving for over here. Okay. So that would mean that the number of square miles that we would find 486 deer in is 54. And maybe this is confusing because I feel like I've kind of gone in a number of different directions. Okay. But think about this. There are 9 deer in 1 square mile. Okay. So if I split the number of deer into equal groups of 9, well, if I divide it by 9, that means that the number I should get is the number of square miles. Okay, because if I have, let's say I have 2 pizzas, or no, let's say I have 4 pizzas and 2 people. Okay, how many pizzas will each person get? Well, each person will get 2 pizzas because there are 4 for 2 people. Okay, and that's equal. 4 divided by 2 gives each person 2 pizzas. So here I already know that there are 9 deer for 1 square mile, and I know I have this many deer. So if I split these into equal groups of 9, that should tell me the number of square miles it takes to get 486 deer. Because I need a certain number of groups of 9 to equal 486. And whenever I have a group of 9 deer, I have 1 square mile. All right, so I'm actually going to cut things off here because we have answered all of that first problem, and we're about halfway through, but I'm going to have you go through a process similar to this as your assignment. Okay, you're going to do it one time, and that's going to be your assignment for tomorrow. All right, so let me know if you have any questions, but you are going to say, you're given an example of this is how many of something are in a certain area, and you need to tell if we have this many, how much space does it take up? Okay. Let me know if you have any questions. We are a good chunk of the way there. If you can do this, you are almost all the way there to being able to use the constant of proportionality to solve ratios.